When you watch an aircraft cross the sky, you see a machine operating in perfect balance. But that smooth, seemingly effortless flight is actually the final result of an intense period of unseen preparation. Up to this point in your training, you focused primarily on flying the airplane. Adding cross-country navigation to that baseline requires you to calculate fuel, monitor weather, and talk to air traffic control, all while keeping the wings level. Because your workload in the cockpit will be high, your ground planning must be meticulous. To build a reliable plan, you need a specific set of tools within arm's reach. Gather a current sectional chart, a plotter, an E6B flight computer, your aircraft's pilot's operating handbook, and blank flight log forms. Throwing these items in a bag safely. Taking the time to convert the raw data from these tools into a comprehensive, step-by-step blueprint is the dividing line between professional airmanship and dangerous guesswork. Step 1 is checking the environment. Call flight service or go online to get a standard weather briefing. Take that forecast and immediately compare it against your personal weather minimums, your own predefined limits for visibility, ceilings, and wind. If the forecast exceeds any of your personal minimums, the flight stops here. This is the go, no-go decision. It is the single most critical command choice you will make, dictating whether the aircraft leaves the ground at all. Once the weather clears you for departure, unroll your sectional chart. Draw a straight, visible line along your proposed route. As you lay out the path, identify prominent visual checkpoints, like rivers or highways, while routing yourself safely away from restricted airspace and high terrain. To make that line useful in the air, take a pencil and add a small tick mark every 10 nautical miles. When you're busy flying, these physical markers allow you to estimate your progress at a single glance, without needing to pull out a measuring tool. To measure distance on the sectional chart, place the 0 line on your departure point and read the nautical mile scale. Next, find true course by sliding the plotter's center hole over a vertical meridian and read the matching degree on the azimuth disk. By securing a safe weather window and locking in the exact physical distance and direction on the map, you have built the structural foundation of your flight plan. Now we need to correct for the Earth's magnetic field. Look at the dashed magenta lines on your chart to find the local magnetic variation and add or subtract that number from your true course to get your magnetic course. That magnetic course tells you which altitudes are legal to fly. For VFR flights above 3,000 feet above ground level, heading east requires odd thousands plus 500 feet. Heading west requires even thousands plus 500 feet. It is very easy to fall into the altitude trap here. You must base your cruising altitude strictly on your magnetic course, the line over the ground, not your magnetic heading, which is where the nose is pointed. With your altitude set, open your aircraft's pilot's operating handbook. Check the cruise performance tables for your chosen altitude to find your expected true airspeed. Take that true airspeed, combine it with the forecast winds aloft, and run them through your E6B flight computer. This calculation provides the wind correction angle you need to stay on track, your required magnetic heading, and your actual ground speed. This section of the flight log shows the result. By dividing your leg distance by your calculated ground speed, you get the estimated time en route. Be sure to add an extra time and fuel allowance for the initial climb. Nailing down accurate headings and time intervals allows you to predict your precise fuel burn. In the air, those numbers dictate exactly how long you can safely keep the engine running. Calculating your exact trip fuel is only the starting point. To avoid fuel starvation, a leading cause of accidents, the FAA requires you to carry a fixed reserve on top of your trip fuel. You must add enough fuel for 30 minutes of extra flight time during the day, or 45 minutes at night. Once you know the weight of that required fuel, combine it with the weight of your passengers and baggage. Complete a standard load sheet to verify the total weight stays below the aircraft's maximum allowable limit. This chart shows how those weights determine your balance. By cross-referencing your total weight with the calculated moments, you verify that your center of gravity falls safely within the manufacturer's approved envelope. The weight you just calculated directly impacts how much runway you need. You must consult your performance charts to guarantee the selected airports have enough pavement for your specific load and the day's temperatures. This takeoff chart gives numbers for departure. By matching takeoff weight to pressure, altitude, and temperature, you identify ground roll and distance to clear a 50-foot obstacle. Apply this process to your destination airport to ensure you have room to stop. These rigorous checks ensure the aircraft actually possesses the mechanical performance required to execute the math you just put on paper. With the math verified, the final step is translating your data into FAA Form 7233-1. This formal flight plan is the official record you will file with Flight Service. Enter your aircraft type and equipment suffix into Block 3. Set your initial cruise altitude in Block 7. In Blocks 10 and 12, enter time en route and total fuel. Fuel must be in hours and minutes, exceeding flight time by your mandatory reserve. Filling out this single sheet puts your intentions on the record. If an emergency happens and you fail to arrive, this form gives air traffic control and search and rescue the exact timeline, route, and equipment details they need to find you. Your planning package is complete. You have a marked sectional chart, a mathematically sound flight log, verified performance limitations, and a fully prepared flight plan form. Because flight planning often takes longer than expected, you may feel pressured to make up for lost time. Do not rush your physical pre-flight inspection. Go through your normal exterior and interior checklists with the focus you applied to your math. Before you start the engine, call Flight Service to file the plan. Once you are safely airborne and clear of the immediate airport traffic, use the radio to contact Flight Service and officially open the flight plan. When you land at your destination, you must explicitly close the flight plan with Flight Service. If you park the plane and walk away without closing it, the FAA will assume you crashed and initiate a costly, unnecessary search and rescue operation. Cross-country flying tests your ability to manage information as much as it tests your ability to handle the controls. Mastering this rigorous ground workflow is the true hallmark of a confident, safe, and professional aviator.